Hi everyone, welcome to my project PowerPoint presentation. My name is Terence Malesa. I'm currently doing my master's studies with the University of Pretoria in South Africa in collaboration with the Institute of Tropical Medicine Antwerp based in Belgium. My project supervisor is Dr. Pamela Opperman and my co-supervisor is Dr. Livio Heath. My project title is the development of serological based vaccine matching technique for foot and mouth disease SARS-2 viruses. Foot and mouth disease virus is a highly transmissible transboundary disease virus that affects domestic cloven hoofed animals. There are 7 FMD serotypes, and out of those 7 FMD serotypes, 3 serotypes occur mainly in the Southern African region, which is SARS-1, SARS-2, and 3. My project will focus on the SARS-2 serotypes, which is widely spread in Africa and has the most antigenic variation amongst each other. Vaccination of domestic cloven-hoofed animals have been proven to be a successful control measure for an outbreaks. And currently there is no vaccine that can confer protection against all 7 serotypes. There is a high need of vaccine improvement which should be accompanied by a constant surveillance survey of circulating FMD viruses to ensure that suitable vaccine strains candidates are maintained within the strategic antigen reserves. The aims of the study is to develop an ELISA technique that will be used to determine if the trivalent foot and mouth disease vaccine will confer protection against the SARS-2 foot and mouth disease topotypes strains. The objectives to achieve the aims of the study are to determine the most prevalent strains within the SARS-2 topotypes, development of an ELISA assay to determine the R value, estimate the protection conferred by the FMD trivalent vaccine against the selected SARS-2 FMD strains. Under my hypothesis, my null hypothesis is that the trivalent vaccine is not 100% matched with all selected SARS-2 topotypes and will not provide protection against outbreaks originating from the selected SARS-2 topotypes. My alternative hypothesis is that the trivalent vaccine is a match to all selected SARS-2 topotypes and it's highly likely to confer protection against selected SARS-2 field isolate. Under the research design, I've placed a map that depicts the areas of FMD serotype outbreaks in the Southern African region. The SARS-2 foot and mouth disease virus serotype is divided into 14 topotypes, and out of the 14 topotypes, we'll select 3 prevalent topotypes that occur in South Africa or in neighboring countries. And then we will draw a phylogenetic tree similar like the one being presented. The phylogenetic tree will contain recent SARS-2 outbreaks from 2009 to 2018 of topotype 1 to 3. We will select 5 strains from each topotype 1, 2, and 3 using stratified sampling method, and we will have a study sample size of 15 strains. The serological relationship between the field isolate and the vaccine can be determined by ELISA, virus neutralizing test, and complement fixation test. The solid phase competitive ELISA will be used in the experiment to determine if the trivalent vaccine confer protection against selected SARS-2 strains. The ELISA method have been chosen due to its specificity, repeatability, and quick to perform than other recommended tests that are used to determine vaccine matching, such as virus neutralizing test method. The solid phase competitive ELISA is based on the competition between serotype anti-FMD specific anti-sera and the antibodies present in the test serum. For my project, I will receive samples from the kettles challenged with the trivalent vaccine. I will test if the antibodies present in the samples will be able to bind with the anti-FMD SET2 strains using the solid phase competitive ELISA. The development of color in the test will indicate the cross-reactivity of the anti-FMD SET2 strains and the antibodies present in the serum. This will also show that they contain similar antigenic epitope. Spectrophotometer will be used to analyze the optical density of color developed in the experiment, and the result of the spectrophotometer will be used to derive the R value. The R value will assist in determining the relationship between the field isolate and the vaccine strain. For acceptance and interpretation of the R value, we need two consistent results. The R value result of less than 0.2 indicate that the field isolate is distantly related to the vaccine strains and it's highly unlikely to confer protection against the field isolate. 0.2 to 0.39 shows that the field isolate is averagely related to a vaccine strain and can be used for vaccine if no closer match is found. 0.4 to 1.0 point out that the field isolate is closely related to the vaccine strain and have the potential to confer protection against the field isolate. The result obtained will determine if the current trivalent vaccine strain is 100% matched to all selected prevalent SET2 strains. Thank you very much for your attention. That will be the end of my presentation.